pleasant morning to everyone. My name is Joyce RANIDO from BSTCM 2K2. And for today's video, I'll be tackling with you the parallel to serial vice versa PC buses and other PC interface used for networking, and lastly, principles of NIC configuration. So without further ado, let's start. So parallel to serial. There are two basic types of transmission modes available in digital systems, which are the serial and parallel transmission. So, parallel transmissions uses one communication line for each bit of the message. For example, to send a message of 8 bits, 8 wires are required from transmitter to receiver. The ensemble of the 8 wires is called a data bus. So, parallel transmission is normally used when the physical distance between the transmitter and the receiver is short, because it is difficult to maintain bit synchronization and long transmission. Typically, parallel transmission is preferred within a device. Communication pathways between the CPU and the memory of a computer are parallel. There are several protocols using parallel data transmission throughout the industry, including parallel PCI, ICA, ATA, and SCSI. The accompanying figure depicts transmission for an 8-bit message using a parallel bus. The second one is the serial transmission. Each bit of the message is sent to the receiver 1 bit at a time, using one communication line. Most communication is carried out using serial data. Serial communication requires less wires and less complex electronics, but to compare parallel data, it must transmit at a faster rate. Examples of serial data protocols including Internet, USB, SPI, I2C, and FireWire, and others. So next, let's talk about the serial to parallel conversion. To convert serial data to parallel data, a set of D flip-flops is needed. The number of flip-flops is exactly the size of the serial data to be transmitted. For example, to transmit 4-bit serial stream for flip-flops are required. A schematic of a 4-bit converter is depicted. The serial data is delivered at the input of the first flip-flop, and bits are successfully transferred to the next flip-flop on the rising or falling edge of the clock. And the next figure shows an actual circuit for a bit converter where 4 bits 0, 0, 0, and 1 are stored at the input of the first flip-flop. With the first rising edge of the clock, the first bit is transferred to the input of the second flip-flop. Successive ticks moves the bits to the next flip-flop until all 4 bits are stored at the output of each flip-flop. In this figure, we have not shown all the circuitry of an actual converter. The converter does not release the parallel set of bits until all bits are transferred and each one is stored at the output of a corresponding flip-flop. Once all the outputs are filled, the converter releases all the bits at once. For this process to happen, the converter is disabled by means of one or more control lines. During the transfer process enables once all the bits are at the output bus. This is summarized by stating that the conversion is carried out in 3 stages. The first one is disable the output bus. The converter can send output data. 2. Load all the bits into the outputs of the flip-flops by moving them 1 bit at a time using the clock. Lastly, once all the bits are loaded, all the flip-flops have 1 bit stored in the Q pin, then enable the bus operation. The 4 bits are sent at once. So, parallel to serial conversion. In this converter, all parallel data is loaded or stored simultaneously into the D-type flip-flops. Once this is achieved, with the help of the clock, data is shifted 1 bit at a time from the last flip-flop. This 2-step process is schematically illustrated in the accompanying figure. In an actual converter, more circuitry is needed. Simply, the parallel data is multiplexed in order to convert it into serial data. The multiplexer will force the parallel data to be shifted one bit at a time through the last flip-flop. The following figure is a diagram of a 4-bit converter. There are 4 flip-flops and 3 multiplexers. Each flip-flop is the output of a multiplexer, with the exception of the first flip-flop, which will represent the least significant bit, or the LSB, of the output serial data. Which multiplexer has 2 inputs known as a 2x1 max and 1 output. The inputs are 1 bit of the parallel data and 1 input from the previous flip-flop. So next, PC buses. A PC bus is known as an address bus, data bus, or local bus. A bus is a connection between components or devices connected to a computer. So, why is a computer bus called a bus? You can think of a computer bus like public transportation or a school bus. These types of buses are capable of transporting people from one destination to another destination. Like these buses, a computer bus transmits data from one location or device to another location or device. A computer bus maintains a strict schedule, picking up and data and dropping it off at a regular interval. So let's talk about the computer bus overview. The bus contains multiple wires or signal lines with addressing information describing the memory location of where the data is being sent or retrieved. Each wire in the bus carries a bit or bits of information, which means the more wires a bus has, the more information it can address. For example, a computer with a 32-bit address bus can address 4 GB of memory, and a computer with a 36-bit bus can address 64 GB of memory. So there are types of computer buses. So a bus is either a parallel or serial bus in either an internal bus or local bus or an external bus, or it could be called expansion bus. So internal bus versus external bus. An internal bus enables the communication between internal components such as a video card and a memory. An external bus is capable of communicating with external components such as USB or SCSI device. The next one is parallel bus versus serial bus. A computer bus can transmit its data using either a parallel or serial method of communication. With a parallel bus, data is transmitted several bits at a time. However, with a serial bus, the data is transferred 1 bit at a time. So here are the most popular computer buses. So there are most popular computer buses, which are the SATA, computer hard drives and disk drives can be stored here, PCI, computer expansion card and video cards, and USB computer peripherals, and lastly Thunderbolt peripherals connected through a USB-C cable. Other PC interfaces used for networking. What is a network interface? A network interface is the point of interconnection between a computer and a private or public network. A network interface is generally a network interface card or NIC, but does not have to have a physical form. Instead, the network interface can be implemented in software. An example here is the Java network interface. Class represents both types of interface. Network interface is useful for a multi-homed system, which is a system with multiple NICs. Using network interface, you can specify which NIC to use for a particular network activity. For example, assume you have a machine with 2 configured NICs, and you want to send data to a server. You create a socket like this. Here you can see it in here, the PPT. To send the data, the system determines which interface is used. However, if you have a preference or otherwise need to specify which NIC to use, we can query the system for the appropriate interfaces and find an address on the interface you want to use. When you create the socket and bind it to the address, the system uses the associated interface. For example, here on the second example, as you can see, I don't know how to read this one. And you can also use network interface to identify the local interface on which a multicast group is to be joined, for example. Here is also an example, as you can see. So network interface can be used with Java APIs, many other ways beyond the two uses described here. So the last topic, principles of NIC configuration. So NIC settings page is used to set the speed, duplex, and MTU of the system NICs, to set the behavior of the bridges in the event of an appliance failure, for example, fail to wire, and to set the behavior of the second port in a bridge pair where the first port goes down, for example, link state mirroring. And that's all for my topic.
Now, let's talk about principles of NIC configuration. The NIC setting page is used to set the speed, duplex, and MTU of the system NICs, to set the behavior of the bridges in the event of an appliance failure, for example, fail to wire, and to set behavior of the second port in a bridge pair when the first port goes down, for example, link state mirroring. Principles of NIC configuration includes matching NIC to slot on PC or external connections such as USB. Microsoft introduced plug and play (PNP) architecture with Windows 95. NIC configuration involves modifying settings such as interrupt request, line, base I/O port, and base memory address. A pleasant day to everyone. This is Shania Eyas from BSTCM 2K2, and I am here to discuss the continuation of the report of Miss RANIDO, and I am here to report about choosing network adapters, wireless adapter, and driver software. Choosing network adapters. It is a confusing task to buy a network card, especially if it's someone's time to buy one, and different types of NICs on the market like PCIe card, USB network adapter also make the purchasing a bit complicated. Then, how to choose a network card? The following are the factors that should be considered before buying network interface card. First one, be careful about the bus type of the NIC card. NIC card can be classified into PCI, PCIX, PCIe network cards, and USB network adapters based on different bus interfaces. So generally, the three PCI-based types of network cards are used to fit the corresponding slots in the motherboard of devices like host and servers, while the USB or Universal Serial Bus network adapter is an external bus standard. So here are the examples, the example of PCIe network card and the USB network adapter. Note that the PCIe network cards are the most popular network card type on the market, while PCI and PCIX cards are only used in old devices. The newly released servers, PCs, and other hosts are commonly designed with PCIe slots. So, next one. Get to know the required speed of the network adapter. This factor must not be ignored when you are confused about how to choose network card. Make sure that your new NIC card speed will fit your network speed. For example, you can expect to reach 10 GB speed by a 10 GB Ethernet card if your ISP only offers you 1 GB speed. Today, almost all network cards can operate at least 1 gigabit speed, which will meet at-home network demands. But if you plan to use the card in your servers that require higher speed to the network demands, handle more network, you better choose 10 GB and 25 GB network card or even the 40 GB network card. Make sure the port numbers of the network card. Commonly, a NIC network card with a single port is fine, which will satisfy most transmissions demands. But NIC cards with multiple ports are great choices for servers or workstations to deal with different tasks. For example, one port of the network interface card can be deployed for delivering core data, and the other ports can be used for transmitting normal signals. This may improve network security. Besides, multi-port NIC cards can provide network redundancy. If one port is unable to work, users can use the other port to deliver the data. Now let's proceed to the next topic, which is wireless adapter. So what is wireless adapter? Wireless adapters are electronic devices that allow computers to connect to the internet and to other computers without using wires. They send data via radio waves to routers that pass it on the broadband modems or internal networks. Most laptops and tablets computers have built-in wireless adapters, but if you often have to install them on desktop computers before adding them to office desktops and establishing a wire network in your office. The kind of adapter you get must match your needs. Types of adapters. First, wireless standards. The radio waves used by wireless adapters have to satisfy one of the 802.11 broadcast standards of the IEEE. The most recent standard in common use of January 2013 is 802.11n. But older adapter models use the P or G standards. These standards determine the speed of data transfer which the adapters broadcast, and all use the 2.4 GHz radio frequency band. Next is the speeds. The oldest standard, IEEE 802.11b, specifies broadcast speeds of up to 11 Mbps. The later model adapters broadcast at IEEE 802.11g speeds that can range up to 54 Mbps. Lastly, the security. Wireless adapters broadcast to signals from your computer with a range of about 200 feet. Anyone with a wireless adapter installed in their computers or laptops can pick up your signal and access your files. Securing your wireless network is especially critical for businesses, protecting sensitive material and their intellectual property. So, to avoid this unauthorized access, wireless adapters use encryption to secure their signals. The WEP, WPA, WPA2 protocols offer password-protected and encrypted transmissions for wireless networks. Your adapter must support these protocols to use them. Most support them. So now, let's proceed to the last topic, which is driver software. So, it is challenging to give a single precise definition for the term driver. In the most fundamental sense, a driver is a software component that lets the operating system and the device communicate with each other. For example, suppose an application needs to read some data from a device. The application calls a function implemented by the operating system, and the operating system calls a function implemented by the driver. The driver, which was written by the same company that designed and manufactured the device, knows how to communicate with the device hardware to get the data. After the driver gets the data from the device, it returns the data to the operating system. Note that not all drivers have to be written by the company that designed the device. In many cases, a device is designed according to a published hardware standard. So this means that the driver can be written by Microsoft, and the device designer does not have to provide a driver.